Hello, you're welcome to our channel once again. Today we shall be discussing how to determine the paint required using the architectural drawing, as you can see what we have on the screen. So you can take your time to sketch it out. So by the grace of God, I will be doing the external walls for the first two floors, the ground floor and the first floor. So I'm going to do for the external now, after which I'll be expecting your own calculation for the internal. So I hope you are with us and I hope we are set. So let's meet up, let's join the main class. Thank you. I want to welcome you to this class. So we are here to calculate the paint required for a building using the architectural design. So you should be able to calculate the paint required without getting to the site. But there are some basic things you need to establish first. You need to establish some basic principles. Number one, what kind of paint are you using? Second thing is that what kind of surface are you coating? Is it a masonry wall? Is it a steel? Is it a concrete wall and the like? So then that will assist. When you know the kind of paint you are using, the product you are using, that will determine the spreading rate you will use in your calculation after getting the square areas to be painted. So I'm going to do a kind of shortcut. Now let us for the external, let us assume we are using G-coat matte. So now we are using what? G-coat matte. What's the spreading rate of this G-coat matte? In case you don't know, we are the producer of G-coat paint. So our G-coat matte can cover between 12 to 13 square areas per coat. So let's just decide to pick the lower one. Let's say we are covering, if you cover 12 square meters per coat. So the meaning is that when you take a liter of our paint of G-coat matte, it will cover an area of wall that has been sealed, meaning it has been prepared, it has been potted or screeded, it has been sanded and primed. That is the meaning of a sealed surface. It will cover this. Now let us go to the areas we want to paint. Now, how many coats are we giving? So before that, we have our drawing we show to you now. So after that, as you can see, we have the drawings now. What is the length of our building? We are considering the ground floor first. The ground floor. But ideally, we are supposed to do, since we are doing the external, so we are supposed to do the external together. We are supposed to calculate for the external hand. Our eyes should be straight, then we'll do our deduction. So we have two ways now to get it. Yes, we do it together. What is our length? So you see from the drawing, from our drawing, we have 11,300 plus, we have 2,340 plus, we have the what? 225 in 3. So I don't want to waste my time, I can do it this way. That's what? this is in mm. So we want to convert it to meter. That's divided by 1000. So that will be 14.315 meters. So our breadth now, using the plan, so you can just decide to either add it up from the up, since we are not given the out dimension. So calculate it through the internal. So what do we have on our breadth? Lots of time, let's just save time. 12.753. 12.753. Now we are dealing with the external. So now to get our, we need the area. So we have two ways to do that. Even though we have projections there, if you look at the shape of the building, it's like this. Let's say the ground floor like this. Am I right? So if you look at it well, you can decide to bring this one here. This one here too, you can decide to bring it here. This one here, you can decide to bring it here. This one here, you can decide to bring it here. So at the end of the day, you still have a perfect square. Now, another thing we need to know is the height of the building. We need to know we have the ground floor and the first floor. So our height will be 3 plus 3 plus. We need to know how the roof slope from our roof design. How does the roof project or slope? What is the roof height? The kind of roof we have there is gable roof. So I know a gable roof we have something like this. A gable roof we have something like this. So this is the kind of roof we have there. So we are constricting our thing to here. This is the first floor, this is the ground floor. So the height we are using now is from here to here, which is 3, which is 6. Then there is a kind of step here, which is about no more than 0.3 meters that we have there in this particular building. At times it can be 600. So we now deal with this one later. This will just be the front and the back. It won't be by the side. Okay? It will be just the front. The gable end will be at the front and the back. So now this one is plus 0.3. 0.3, which is 6.3 meters. Now we need to now get the area of all the 4 sides, assuming that our levels are of the same. We assume that the heights are of the same. After that, we will now deduct the areas that we added there that did not go up. The area that we added there that did not go up, we remove it from our areas. It's here. Yet it doesn't matter. We can remove it from here to here. But the meaning is that it will be more. When you remove this one from here to here, it will not stop here. It will come here. So it means you still have to reduce it. So let's just do the row first. We will now deduct the ones that are not involved. We also deduct the doors that we have. All the external doors. Call them openings. Both the external doors, the external windows. Maybe there is a veranda that has an axle. Those areas we need to remove them. Is that clear now? So we have 2 ways to calculate for this thing out. As we all know, we can decide to use the graph formula, and that is 2 into L plus, using this formula, then height. This is the first formula. We'll use it and we'll use the second one. So let's see. Our graph now be 2 into what is our length? 14.315 plus our breadth 12.75. Let's approximate them to 2 decimal points. So this will be 2. This will be 5. Okay. Times the height is what? 6.3 meters. All in meters. So this will give us what? This plus this. That's 7 point what? Times 2 times 6.3, 41.082. So now be in square meters, because we are dealing with meter. All these things were in meter. Now it's not going to be in square meters. This is the entire areas I want to paint. Let's now do it side by side and see if we will still get the same thing. Remember, our length is this side and this side. So let's calculate for the area of the length. Area of the length is a square area or a rectangular shape, as the case may be. So the length is what? 14.32 times the height 6.3 meters. So what do we get? 2. So remember, the length are 2, this side and this side. So let's multiply it by 2. What will that give us? 180.432. 432. Now, this is our first method. This is method 2. So whatever you get, this is our method 1. So the breadth, our breadth is what? 12.75 times 6.3 meters. What would that give us? 80.3. So because we have two sides of the breadth, the front and the back, so times 2 will give us what? 160.65. So because we are approximating this, that's why I got this. So because we are approximating. So now let's add these two together. This and this. What are we going to get? 341.08 square meters. Can you now see method 1 and 2? Can you now see that we arrive at the same answer? But look at the step we went through here. Look at, so it depends on your choice. So now we need to deduct the areas we are not painting, like all the openings that are external. So now let us itemize them. We need to list them. The openings that are on the length, on the right side of the building, the one on the left side, the front and back, their sizes. So in order not to omit anyone, so we don't do it randomly, do it side by side. Let's start from the right side. So what are the openings that we have on the right side? So look at, we need to check the plans, the two plans. The windows are of 1.2 meter height. So let's list out the length of the windows.
I think that should be 600.
Yes, 600. The toilets are 600, so that's 0.6 minus 0.6. We have 2 of it.
Yes, 2 of it.
So we just slash it this way. This means times 2. So we don't do it this way. So okay. On the first floor, so how many doors openings do we have on the?
We have 4.
So let's have them. So what's our sizes?
First one, 1.2 and 1.2.
1.2 by 1.2.
That one is also
Times 2. We have this. So mind you, all these are in meters. We are using meters. So in case you know how it is, 2 meters are. So we have 0.6 by 0.6 in 2. So we can both put it in these 2 into 4. we are still on the right side. What will this give us? What will this give us? 1.14. What of this?
2.80.
So when you look at the plan of the upper floor, it has, there are some additional that we need to consider. This is, there is a recess, goes this way, even has a projection here. So even here there is a window here. We have not considered these two walls into our total, the entire area that we did earlier. So we are still going to consider these two walls. This one is here, it has been considered, as we pushed here. So please take notes. Also, we have not considered this projection here. This two. Yeah. So we are going to consider them.
So what about is another opening there? That opening now.
Yeah.
Yes. Are we going to consider as a part of this writer?
No,
it's not.
It will be on its own. But after the right left, so the ones we have there will add it. So we need to consider this, which have been omitted. So we are going to add it. Let's have to share this way. So let's do that now before we come back here. We got 341 and 0.0 08 or 07 square meters. 08. So now we need to add this recess, these two sides, and this projection. What is the length of this space? Now we have wall from our drawing. This 900 walls. This is 900. This one is the 1.5 watts. 25 to 1. So this one and this one, which are 1 times the height 3, but it's not from the ground floor, it's just at the upper floor. So this is just at the upper floor. So times 2 for this side and this side. So that will give us what? 6 square areas. Then this and this, that's 1.53 times the height 3 by 2 again. What would that give us? So now let's add it together, everything together. 56.3. That's the general external. So now we want to do all the ones that we are going to place are there. We have done for the right side. So for the left side, what do we have there? The other length. What are the openings that we have there?
0.6 in 3 places.
Toilet window?
Yes.
Then
the one for 1.2 in 2 places.
And 2.88. What is this? How do you give us? So okay, so since there is no opening on the left side, so now the front, what are the openings that are facing the front? 1.2, we have 1.2 by 1.2 in 2 places.
We have, there's an entrance. This one is, I think it's a view.
1.5 by 2.1, which is the height of the door. It is a beam, that's 2.4. What we have there is a beam, so it's 2.4. So someone should do this. What is again?
We have another window.
Still front, Abby?
Yeah, still front.
What's the dimension?
I think.
Okay, this is 1.5.
Yes, 1.5 now.
So someone should Type that for us. So 1.2 by 1.2.
No, that 1.2 is just 1.
I know. This is it. So let's have this and this. Then 1.5 times 2.4.
This is first floor we have.
So this is for the ground floor. For the first floor we have
1.5 by
1.5 by 1.2.
Yeah.
We have considered it together. Okay. That's 1.5 by how many?
Just 1. Then we have.
So we have an opening there as in 3.0 by 2 meters. And 6. Is that all? So we now add all these our openings, then we deduct it from here. So that will give us the area and the actual area we want to paint. But before we even go, we now need to add our gable end to this. So someone should add up this for us. Now the gable end. So we need this height. And our building is this. This is the eve projection. So our width of the building is 12.1. 12.8. 5 meters. So now the height of this about 1.8 meters. 1.8 meters. So we need to calculate this area. There is 1.8 meters. Sorry, the roof cable was not this way. It was facing, yes, we have a gable for the projection, and the other gable, the roof was sloping to both the front and the back. So this is our length, which is 14.31. This is what we have. So the roof is sloping this way, that way. .1. So now we need the area of this triangle. We know it. Let's bring it out as this. This is 14.32, and we have this as 1.8. What is the area of a triangle? That is, the area of a triangle is half base times height. So half times, what's our base? 14.32. Our height is 1.8. What would that give us? 25. So, and we have it on the other side too.
Okay, on the right and the left side.
Yes. So what would that give us? 50. So 51.6, 0.6. Then we have this projection too as a small gable. So what's the width of it?
The projection?
Yes, the width. Yeah, we have about 1.2 meters. So what's the width? Now let's calculate it at 2.38. So now that would be half base, half times 2.38 times 1.2.
What would that give us? 2.856. Eh? 2.856. So that is 2.9. So what will this give us? Addition of these three. This is 51. So now, what is the addition of this? 24.72. 24.72. Now, required area to be painted now is our 410.8 less openings. And the openings, the total openings are what? 24.72. So what will that give us? 435.5 less. How will you be 435? Say less, which is minus 386. 386.08. So this is the actual areas that we have to paint. So that is what we have to calculate for. So we'll continue from here in our next class. Alright, if you have any question, you are free to drop it at the comment section. Do not forget to share this with your colleagues that are into the field. Alright, thank you. Bye.